Alright, welcome to this episode on how do we pass our Common Core Algebra regions. And in this case, we're going to be looking at average rate of change. So let's start with this question. We already saw how to find the slope of a line, how to graph a line. Well, in this case, this is exactly what we're going to be doing. It says given the functions, and we have g of x, f of x, and h of x. And this is g of x, this is g of x, this is f of x, and this is h of x, right? So given these functions, it says let's see if I can put it. Wow, okay, so go here and go here. Okay. So it says list the functions from greatest to least by average rate of change over the interval of x represents all the numbers between 0 and 3, including 0 because he has the or equal to, and including 3 because he has the or equal to. So in other words, I am going to go from 0 all the way to 3. X is going to take on those values and see what y is. All right, in other words, I'm going to find the rate of change. I'm going to find the slope. So let's start with g of x. Now, it's easier to just graph the function when you have it like that. Do not make the mistake, okay, on the regions to mix this function with this one. This does not have to do anything with this one. So press y equals. Okay, clear this out. That was for earlier. And now x squared, okay, minus 2x. So this is the graph of g of x. Now this really doesn't tell me much. I need to look at the table of values. So there you go. So remember, I'm going from x equals 0, okay, to x equals 3. So the order pairs are the following. When x is 0, I have 0, 0. And when x is 3, I have 3, 3. Okay, these are the values for g of x. This is what's going to help me find the slope. You remember how the slope goes, right? So this is x, this is y, this is x, and this is y. Okay, now let's find, okay, so for f of x, we already have them here. For f of x, I'm going to put them over here, the values. For f of x, we have 0, 1, and we also have 3, 7. Okay, and now let's list the values for g of x. I'm gonna zoom in so you could see better, and then I'm gonna zoom out. Okay, here. So when x is 0, y is 2. So I have 0, 2. And then when x is 3, y is 9. So 3, 9. I thought it was gonna be like 8, but no, I see a little gap in there. Okay, now let's find the average rate of change. In other words, the slope. So for g of x, I have the slope is y2 minus y1 over x2 minus x1. So you know what, I'm gonna write it. This is what the slope. This is how you find the slope. y2 minus y1 over x2 minus x1. So now let's replace these values. Let's call this the 1s and let's call this the 2s, okay? So I'm going to call this the 1s and I'm going to call this the 2s. Hopefully you could see that. If not, I'll zoom. You know what? I have space. So let me zoom in. All right. So 3 minus 0 for g of x, right? The slope of g of x. 3 minus 0 over 3 minus 0. Okay, 3 minus 0 is 3, 3 minus 0 is 3, 3 divided by 3 is 1. So the slope here is 1, the average rate of change is 1. So that is for g of x. Now let's go to f of x. So here, x, y, the 1s and the 2s. I always like it like that. So y2 minus y1 over x2 minus x1. 7 minus 1 is 6. 3 minus 0 is 3. The average rate of change, 6 divided by 3 is 2. All right. That would be actually the slope, right? And if we were to graph something, this would be like 2 over 1. 2 up and 1 to the right. You saw that in the previous episodes. And now for h of x. All right, so let's see if you can start without me. Okay, so these are the slopes. So I'm gonna label them. I'm sorry, I'm gonna state what the slopes are. So for g of x, the slope was 1. For f of x, the slope was 2. And for h of x, the slope was 7 over 3. So which one from greatest to least, correct? From greatest to least. Well, let's see which one is the greatest. 7 over 3 is greater than 2 because 6 divided by 3 is 2. So 7 over 3 is greater than 2. Okay, then 2 is greater than 1. So we go from h of x, then f of x, and then g of x. Got it? All right then, so select the correct choice. Let's move on to the next question. All right, 87. Let's see what this one says. An astronaut drops a rock off the edge of a cliff on the moon. The distance d of f in meters the rock travels after t seconds can be modeled by the function d of t equals 0.8 or 0.8 t squared, okay, multiplied by t squared. Now question, what is the average speed in meters per second of the rock between 5 and 10 seconds after it was dropped? The average speed, remember, average speed. All right, so what do I know? Well, first of all, we know that they want the average speed of the rock between 5 and 10 seconds. So we're going to have to plug in 5 and then 10 and then find the average rate of change, which is basically the slope. So let's see now. Okay. So it's 0.8 t squared. So 0.8 or 0.8 times, okay, 5 square. All right, so we got 20. So when x is 5, I got y being 20. Now let's see what happens when x is 10. So I'm just gonna go here and replace, right? And well, 10 squared is 100, so really it's not a big deal. And we got 80. Okay, the average speed. Well, remember how to find the slope, the rate of change? y2 minus y1 over x2 minus x1. So y2 minus y1, and I always make the second pair the 2's and make the first pair the 1's. Okay, 10 minus 5. And now these, okay, 80 minus that, 20 is 60. 10 divided by 10 minus 5 is 5. 60 divided by 5 is 12. Okay? So now make your selection. The average speed, what is it? Right here. Okay. Alright, so what the problem wants was the average speed of rate, the average rate of change. In other words, the average speed. We found it, 12. Now, what does x and what does y represent? X is the time in seconds, and y, d of f, is the distance. So at 5 seconds, the rock travels a distance of 20 meters. At 10 seconds, the rock travels a distance of 80 meters. That's it. That's all there is. Let's move on. All right. So this one. The graph below shows the distance in miles, okay, m, hiked from a camp in H hours. Okay. So what? So, which hourly interval had the greatest rate of change? Okay, from hour 0 to hour 1, from hour 0 to hour 1. To hour 1. Right here. Or from hour 1 to hour 2. Or from hour 2 to 3 or 3 to 4. Well, how do I find the greatest rate of change? Remember, rate of change is the change in this triangle means delta. The change in the up and downs, in other words, the change in the y over the change in x, which is the same thing as to say y2 minus y1 over x2 minus x1. My phone. Put it in vibration. All right. Cut you. Oh, you thought I wasn't going to cut you. All right. So, catch you. Let's see. From 0 hours to 1 hour. 0 hours to 1 hour. The coordinates at 0 are 0, 0. The coordinates at 1 hour are 1 hour and 2 miles. So we have 1, 2. Okay? Now, what is the average rate of change? Easy. Let's figure out using the slope. So y2 minus y1. 2 minus 0 is, let me model it once again, but later on in future problems, I'm not going to do this. 2 minus 0 over 1 minus 0. Okay? y2 minus y1 over x2 minus x1. So we get 2 minus 0 is 2 over 1, which is 2. So the average rate of change is 2. Now let's figure out what the average rate of change was, okay, from 1 hour to 2 hours. Okay, from 1 hour to 2 hours. So this is 2 hours. 2 hours goes with 3.5 miles. See that? 2 hours go with 3.5 miles. So 2, 3.5. So then our two pairs are the following. We're talking about from the first hour to the second hour. So on the first hour we have 1, 2. 1, 2. On the other one we have 2, 3.5. Okay? So let's use the slope formula. And this time I'm not gonna write the whole thing. You write the whole thing. So we have 3.5 minus 2. What is that? Okay, this is x, this is y, this is x, this is y. So 3.5 minus 2 is 1.5. So we have 1.5 on top, and 2 minus 1 is 1. So it's just 1.5. Now, from the second hour to the third hour. Yeah, I'll do that one, and then I'm going to explain something to you so you don't have to kill yourself with this. So from the second hour to the third hour. On the second hour, okay, on the second hour, we have 2, oh no, I don't want to do that. Okay. We have 2, 3.5. I'm better off writing with the pencil. Okay. Alright, so that's the second hour. The third hour, the corners of the third hour, let's look at them. 3, 4.5. See that? Okay, so 3, 4.5. Alright, let's use the slope. So y2 minus y1, it's 1 because 4.5 minus 3.5 is 1 over 3 minus 2 is 1. So the average rate of change is just 1. So now I'm going to give you the specs on this. The answer, my friends, okay, the answer to this question is going to be number 1. Okay, from 0 to the first hour, from hour 0 to hour 1, you have the greatest rate of change, and you saw it because we calculated. Look, hour 1 was, the rate of change was 2. Then from 1 to 2 it was 1.5, and then it went down to 1, and the other one is gonna go down as well. Okay, so I'm gonna explain to you why. The steeper a line is, the higher the rate of change will be. Okay? The flatter it gets, the less rate of change, the smaller the rate of change it is. Okay? And if the line is flat, there is no rate of change. We saw that in one of those previous videos that I made, that a flat line has zero slope. Slope is also the resistance, okay, or to the steepness. The steeper, okay, the greater the slope, or the greater the rate of change. The flatter it gets, the smaller the rate of change, the average speed, the slope, however you want to call it. So try to understand that, because in problems that where they ask you to justify this, you will have to write, okay, a justification for how steep the line is, or to justify why the numbers get smaller. All right, let's do the next problem then. All right, here. Let me see. All right, here we go. It says, whatever you pronounce this family, Jamison, whatever. The Jamison family kept a log of the distance they traveled during a trip, as represented by the graph below. So this is your little graph. During which interval was the average speed the greatest? And then you got the choices. So please read the choices. The first hour to the second hour, the second hour to the fourth hour, the sixth hour to the eighth hour, the eighth hour to the 10th hour. So how am I gonna do this? The same way we've been doing it. Remember, they will ask you about the average speed of whatever, the average rate of change, average slope, average whatever. So look, interval. Let's see now. From the first to the second interval, okay? It was 1 hour to the second hour. So it's 2 minus 1. Y2 minus Y1. So it's just a 1 hour, okay? 1 hour, and they travel a distance of what? From 40 to 110, that's 70 miles. So it's 70 miles here. So how do I represent the average rate of change? 70 over 1. See that? Okay. Now this says from the second hour to the fourth hour. From the second to the fourth. Oh, second to the fourth. How many hours is here? 2. Actually, you know what? Let's pretend that I'm doing the slope and I'm gonna put it in order. So it's 2 hours. And then what was the distance? The distance was 70 miles per hour. From 110 to 180, they travel 70 miles per hour. Okay, 70 divided by 2 is already 35. Here it was, let me put it backwards. They traveled 70 miles in 1 hour. Here is 70 over 1, that's 70 miles. Here, 70 miles over 2 hours, that's actually 35 miles. All right. How about this one? From the 6th to the 8th hour. 6th to the 8th hour. 6th to the 8th. So, sure. 6th to the 8th hour. There's 2 hours. And the distance is from 230 to 350. That's 120 miles. Okay? Guess what? 120 miles in 2 hours is the same thing as an average of 60 miles per 1 hour. So 70 over 1 is still the greatest. And I'm not going to go with all that. I'm just going to tell you that you already know what the answer is. Because it says from the 8th hour to the 10th hour. The 8th to the 10th. Look at that. There's not much gain. And look, the line is almost flat. So then, winner is choice number 1. If you don't understand it, watch it again. All right, let's move on. Done with this page. Problema numero 9. All right, so wow. Hopefully you could see this. I could see it, and I'm blind. All right. So the table below shows the average diameter of a pupil. Pupil, that's how you say it? Yeah. In a person's eye as he or she grows older. Ha ha ha. What is the average rate of change in millimeters per year? Millimeters per year, okay, of a person's pupil diameter from age 20 to age 80. Look, average. We're talking about slope. We're talking about y2 minus y1 over x2 minus x1. So then, what am I going to do? I'm going to look at it. Let's take a look at the points. From age 20 to age 80, we're talking about this. So these are the 2 points that I'm going to take into account. So I'm going to take my beautiful calculator because I'm lazy, okay? I'm going to press alpha y equals, I'm going to create a fraction, and I'm going to put the following. y2 minus y1. Which one is y2? 4.7 or 2.3? Of course. So 2.3, okay, minus y1, which is 4.7. Okay? And then here, remember, always the y2 goes first. In other words, you don't start at the starting point. Although you're still gonna get the same amount, but you don't start at the starting point. Start at the other one. So let's see now. 80, okay, that's x2 minus 20, which is x1. And my friends, we got an answer. You could see it. If you cannot, you're blind. So look, negative 0.04. Joey enlarged a 3-inch by 5-inch photograph on a copy machine. He enlarged it 4 times, okay? The table shows the area of the photograph after each enlargement. A photograph is a rectangle. Length times width is the area, all right? And it was enlarged 4 times. You always read the important information and you highlight it. I don't have a highlighter right now, so boom. Enlargement. 1, no time, first time, second time, 3 time, 4th time the enlargement happened. So, and this is the area. And I caught you again. Damn, today I'm very jokester. All right. So, let's see. What is the average rate of change of the area from the original to the 4th? Oh, please. From the original to the 4th. We already know what to do, right? Okay then, so get to work. Yeah, the slope. Hurry up. Beautiful. Do me a favor, if you're just watching this, if you're not my student, that's fine. If you're my student, put this J over here. So I know that you actually watch this. Okay, okay. Boom, 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 boom. Next question. Number 92. Again, we're dealing with average rate of change. So I'm gonna read it and then we're gonna zoom in. Firing a piece of Firing a piece of pottery in a kiln takes place at different temperatures for different amounts of time. The graph below shows the temperatures of a however you pronounce this, kiln, while firing a piece of pottery after the kiln is preheated at 200 degrees Fahrenheit. All right, I have no idea what I just read. One thing I know is that they're going to ask me about the average rate of change. So look, during which time interval did the temperature in the kiln show the greatest average rate of change? Okay, so we have choices from 0 to 1 hour, 1 hour to 1.5 hours, 0.5 hours, 2.5 hours to 5 hours, 5 hours to 8 hours. Time for you to think. Go ahead. I'm going to tell you something. This does not apply. This does not apply. This one applies. This one applies. And this one applies. All right. These are the 3 that actually I feel will be part of our answer. So let's see. From 0 to the first hour. Let me increase the sizing here. Let's see what's up. Okay. So the temperature shows the greatest average of rate of change at, well, let's figure out. From 0 to the first hour. It increased. Let's see, it increased. This is like 1, let me see, if this is 400, this has to be 600, and this has to be 800. So I'm gonna say that this is, oh well, duh, Becker, it says it right here. So 1,700, okay. So, and this is 0,200. So this is 0,200. Let's find out the rate of change. Well, y2 minus y1 and x2 minus x1. So from 200 to 700, there's an increase of 500. So I'm gonna write it right here. 500 over the interval of 1 hour. Okay, 1 minus 0, 0. So it increased by 500. The temperature, okay, the average rate of the temperature increased by 500. All right, now let's go on to from the first hour to 1.5 hours. The increase was 200, and 1.5 minus 1 is 0.5. So 200 divided by 0.5, let's see what it is. 200 divided by 0.5 is 400, not 500. So from here to here is the average rate of temperature increased by 400. No. How about here? Well, 2.5 minus 1.5 is 1. Okay, let me put the 1 here. And then 5,100, 300, what? 5, no, it's not 5,000, is, oh yeah, sorry, 1,300, and this is 900. So the average right here, it went from, okay, the temperature went from 900 to 1,300. That's 400, an increase of 400. So 400 over 1. So now you should understand that from 0 to 1 hour was the greatest increase, average increase in temperature. So then choice number 1 is the answer. If you still don't understand, please ask or rewind it. Okay? Remember, we're looking at slope, we're looking at average rate of change. That's all that we are doing. Below shows the cost of mailing a postcard in different years. Okay. During which time interval did the cost increase at the greatest average rate? Okay. Same thing. Same thing. So let's see. Let's start from, okay, 1898 to 1971. So how do you find the average, what do you call it? The cost, the average cost, the average rate of the cost. Okay, how do you find that? Same thing, slope. So how do you do it? All right, for choice number 1, that will be y2 minus y1. Okay, because the cost depends on the year. So 6 minus 1 over 1971 minus 1898. Okay, what do we get? We get 5 over 73. So, and which is basically nothing more than 0.7. All right, 7 cents. So now your job is to find out for the other choices and see which one is the greatest. As simple as that. What? On the second, from 1971 to 1985? What? No way. It increased by 57 cents. You're onto something good. Continue. Alright, so basically find out the other two. I already showed you how to do it. And just in case you're wondering, yes, the choice is number 4, but you have to show the work as to y. Okay, show the work. Even if you're not my student, show the work, because that's gonna get you points. Okay, so you know where I'm going with this. Okay, compute that. That's as much as I'm going to help you with. Let's move on to the next question. Oh my God. Alright, so this graph shows the average temperature of the Earth's surface from 1950 to 2000, according to one source. Oh, okay. So, let's go to the question. During which years did the temperature variation change the most per unit time? Okay. Explain how you determine your answer. During which year did the temperature variation change the most? I don't know. So let's see the variation. From 1950 to 1955, there was no variation at all. From 1960 to 1960, from 1955 to 1960, 1955 to 1960. No, I don't see any variation. I mean, there is variation, but I don't think this is the greatest one of them all. But we could always compute it. Let me see, negative 0.1, negative 0.2. Okay. This would be from 1955 to that. So the variation will be what is this? Negative 0.01. So this is point. Oh, I see. This, my friends, will be 0.05. Then 0.10, 0.15, 0.20. Oh, okay, now I get it. So this is negative 0.15. All right, cool then. So the variation here will be, for x, it would be 5 years, right? So it will be 5 years. And the variation, the change, okay, from here to here will be just 0.05. So we have it increased at 0.05. Oh, okay. Now let's take a look at the next one. What will the next one be? From 1960 to 1965. All right, 1960. Our point is 1960. Duh. This point right here is 1960, comma 0. And this point here will be 1965, comma negative 0.15. So negative 0.15. Man, this is hard. Okay, so now let us compute this thing with the calculator. All right, so now I'm gonna make this bigger so you could see. All right, good. So let me start with this one. All right. So let me see. What is 0.05 divided by 5? That is 0.01. Okay. Didn't expect that. Now here, the next one. In the next one, I'm gonna do the following. So from here to here, we have negative 0.15. That's the change in x. The change in, no, sorry, that's the change in y. The change in x would be from 1960 to 1965. So that's only 5 years. So we have So negative 0.15 divided by 5 years. And that is a change of man, I should have just worked the problem out somewhere. This is a change of negative 0.03. Okay. Then we're gonna have the others. So let's see now. This one we shouldn't even be worried about it because this one doesn't have any change in temperatures. Look, remains at negative 0.1. How about this one? This one seems to be constant. Okay, it seems to have a difference in years of 5 years, right? And it seems to be the same for each of these intervals. So all I have to do now is just measure the, okay, so the X difference is 5 years, okay? And now the Y, how much did it increase? It increased by, look, from negative 0.1 to 0 is basically 0.1, so it increased by 0.1. So this is sorry. So the change in Y is 0.1 and the change in X is 5. So that's what I'm going to do. So 0.1 divided by 5. It increased by 0.02. Okay, 0.02. The variation was 0.02 of a degree. 0.02 or 0.02, doesn't matter. All right, so now we can answer this question. During which years did the temperature variation change the most per unit time? Okay, so during 1960 to 1965, look, the variation was 0.03. Okay, 0.03. Now, whether the variation is positive or negative, we're talking about variation in temperature. We're not talking about, oh, which one is more, positive numbers or negative numbers. No, the variation here, it went down 0.03 of a degree. As opposed to here, it only went up 0.02. Okay, here, it went up by 0.0. Wait, no, something is not right. I didn't measure this one. What was it again? Let me see, 0.05 divided by 5. Okay, the variation here was 0.01. So then this is not greater than this one, and this one is not greater than this one. In terms of variation, in terms of changing, remember something, okay? So this right here is the greatest change, the greatest variation. So we're going to answer the following. So we're going to answer that in the years, and I'm going to actually, let me see if I can write in ink. Okay, so during 1960 to 1965, okay, the graph has the steepest slope. Now you don't want to answer that? Easy. Then you're right. During 1960 to 1965, okay, the graph shows a variation, okay, it shows a variation in temperature of 0.03. Okay, or you could say it shows a variation, or shows a decrease, okay, in temperature variation of 0.03. Got it? All right then. So yeah, basically that's what we could have just looked at the graph, and we could have actually determined that this is the steepest of them all. These don't look as steep as this one. Look, 1, 2, 3, and 1. So 3 down, 1 to the right. Here you're going 2 up and 1 to the right. 3 over 1 is not lower than 2 over 1. Got it? And this one was 1 over 1. So no. Alright, wow, 94 took me like a long time. Alright, 95. Okie dokie. So the table below shows the year and number of households in a building that had a high-speed broadband. For which interval of time was the average rate of change the smallest? So here we go again. What you're going to do is you're going to find the slope, the rate of change. Okay, y2 minus y1 over x2 minus x1. And you're gonna have to do it for the intervals. So here they give you the choices. So basically you're going to apply yourself according to the choices from 2002 to 2004. All right, so from 2002 to 2004. So this is y2, this is y1. I mean, this is y2, this is y1, x2, x1. So how do you do it? I'm just gonna give you the first example. So it's 2004 minus 2002, okay, over 23 minus 11. Okay, that's for choice number 1. So then show work for each of the choices, please, and determine the best answer. Alright, so you did it. I'm not gonna do it. I'm just showing you how to do it. You have a calculator, so now figure out what the answer is, and please show work for each of the choices. Very good. So let's move on to the next problem. Alright, 96. Which function has a constant rate of change equal to -3? So the rate of change, remember how it goes. -3 means that it's decreasing. Okay, decreasing meaning going down to the right or going up to the left. Same thing. But at the end of the day, it has to decrease. So let's see how we do that. Let's try this one first. What is the change? Okay, 5. What is the slope from here to here? What is the change here? It goes up by 3, right? Here it went up by 1. From here to here it went up by 3, plus 3, plus 1. Wait, hold on a second. This is a plus 3, a plus 1. I'm never gonna get -3. Do you comprehend what I'm saying? Alrighty, let's take a look at these points. So from here to here, let's see. From 5 to 2 it decreased 3. Alright. From 2 to -5 it decreased freaking 7. So no, because look, this is 3 over 1. It increased by 1. From here it increased by 1. Yes, it increased by 1. I get it. The x, remember what the slope is? The change in y over the change in x. The change in x was always 1. But then the change in y was first at the beginning it decreased by 2. It was -3. But then from here to here it decreased by 7. So it's not linear. When it's linear, it decreases at the same rate. Let's take a look at this one. Alright, so let's start at this point, which is a nice point. Okay? So I'm going 1, 2, 3. Nope, you see, it doesn't decrease by 3. Or the rate of change is not -3. The slope is not -3. Look, 1, 2, 3. The change in y over the change in x is the slope. It's not 3. Fine. Then let's take a look at this one. Wait, but this one is not even solved for y. Solved for y. Fine. What is happening to y? It's been divided by, it's been multiplied by 2, so I'm gonna divide by 2. Divide by 2, divide by 2, or I could just divide the whole thing by 2. It really doesn't matter. 2 divided by 2, 1. -6 divided by 2, -3. X plus 5. What is the y-intercept? 5. What is the slope? negative 3. Please don't ever say that the slope is negative 3x. Alright, because you're wrong. So the slope is negative 3, so choice number 4 is our choice. Oh my God. This was horrible. Alright, so we got it. Now, let's move on to the next question. Number 97. Okay, so what does this one say? This one says, a graph of average resting heart rate is shown below. The average resting heart rate for adult is 72 beats per minute, but doctors consider resting rates from 60 to 100 beats per minute within normal range. So, what is the question? The question is, which statement about average resting heart rates is not supported by the graph? Look at this. Very important. Which one is not supported by the graph? So, how am I going to answer this question? The answer is, I don't know. Oh, wow, Becker, you're the best then. Well, doesn't matter. So, let's continue with this. Read the choices, please. Got it? Okay. So, a 10-year-old has the same average resting heart rate as a 20-year-old. A 10-year-old. The 10-year-old is right here. All right. And it says that it has the same average resting heart rate as a 20-year-old. Where's the 20-year-old? Here. Do they look like they have the same average resting? No. Look, from 20 to 50, it's constant. Okay? See, the average heartbeat is 72. 10 is at 90. Bex, you're the best. You found it. Yes, so then this is not supported by the graph. All right. A family is traveling from their home to a vacation resort hotel. The table below shows their distance from home as a function of time. Okay, fine. So time, distance. Cool. Time is always the x-axis, by the way. Determine the average rate of change between 2 hours and 7 hours, including units. Okay, so you do this one. I'm just going to give you time to do it. Okay? All right, let's move on to the next question. The graph below models the height of a remote control helicopter over 20 seconds during the flight. All right, during flight, whatever. So, over which interval does the helicopter have the slowest average rate of change? What do you think has the slowest? Exactly. Look at this. The average rate of change might be negative, but hey, it's very high. Here, I think is higher than here. And here, I think is higher than here. So from 5 to 10. So my answer is choice number 2. I hope you understood that. I didn't have to. You could have calculated, definitely. Yes, of course. All right. All right. So here, voting rates in presidential elections from 1996 to 2012 are modeled below. Brrrr. So, which statement does not correctly, interpret voting rates by age based on the given graph? All right, so let's start looking at some answers right here. For citizens 18 to 29 years of age, the rate of change in voting rate was greatest between years 2000 and 2004. 18 to 29. All right. Gosh. 18 to 29. So that's what the first choice said. So they have the greatest average rate of change 2000 to 2004. 2000 to 2004. Was it the greatest? The rate of change in voting rate was greatest between. This is, yeah, it is correct. That's the greatest. Oh my God. Which does not correctly interpret. Oh my God. Okay. So the first one is correct. So therefore, it's not our answer. So it's not our answer. Let's read the second choice. From 1996 to 2012. All right. From 1996 to 2012. OD. Okay. The average rate of change was positive for only 2 age groups. Positive. Okay, let's see. So positive, 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 negative. Negative, positive, negative. No. Positive, positive, positive. No, that's not true at all. Look, the rate of change here was negative. Okay. So 2 age groups, that's not true at all. So then choice, this is not true. Therefore, or this is incorrect. Therefore, that is the answer that we're looking for. Got it? And about 70% of people 45 and older voted in the election. 45 and older. Let's see what's going on. 45 and older. This is for 70% of people 45 and older. So yes, it is correct. Right here is the 70. Okay. Now, the voting rates of eligible age group lies between 35 and 75%. 35 and 75%. Yeah, that's true. Alright, so anyways, answer was choice number 2.